My name is MD NAUMAN AKHTAR. I am from MUZAFFARPUR Institute of Technology. So this is the question given by SkiFi lab of tall building design. Start the designing using ETAP software. Go to the ETAP, select file, go to new model. Click on OK. Initial setting. Select the uniform grid line to 4 and the spacing of grid in x direction y direction is 6 Number of stories is 23. Let's say typical story height and bottom story height is same as 3. Here we will use the concept of similar story building. Use the custom story data, edit story data. So from story 1 to 8 it is similar as given in the question. So we will select story 8 as a master story and we will change the whole similar to story 8. So from story 1 to 8 it is similar, and from 9 to 14 it is similar. So we have selected story 14 as a master store. In the same way story 19 we have selected a story as master story. Click on OK. Click on grid only. Click on OK. So first we will define the material property. Add new material. Select the material type to concrete. It is M40. Click on OK. One more time click OK. Add new material, which is material type change to rebar. HYSD grade is 500 as given in the question. Click on OK. Click one more time OK. One more material we have to add, that is mile 250. Under rebar material click on OK. One more time click OK. Click one more time OK. Now we will define the section property. Go to frame section, add new property, select concrete, change the property name to, and the dimension given is 500 cross 500. Change the material to M40. Change the depth is 500 mm and the width is also 500 mm. Click on modify story bar. Make sure the design type is set to column. Longitudinal bar is HYSD 500. Confinement bar is mile 250. Select the default value as shown. Click on OK. Now click OK. So in question there are 3 dimensions given of the column. So we will add the copy of the property. Change the property name to column 550 cross 550. Material type is M40. Change the depth value, that is 550 mm, and the width is also 550. Click on modify zero bar. So there is no change because we have selected the copy of the first column dimension. Click on OK. Click on OK. One more dimension which was given, select copy. Change the property name to make dimension, that is 600 cross 600. Change the depth and width ratio, that is 600, and the width is 600 mm. Click on OK. So in question it is given auto select in this 3 dimension. So we will add a new property. Change the special to auto select. Change the property name to column auto select. Change the auto select design type to concrete. Select all 3 dimensions which I have mentioned before. Click on add. Now click on OK. In the same way we can do for the beam also. So add new property. Change the auto select to concrete rectangular. Select concrete. Change the property name to beam 500 cross 300. and the material is M40. Change the depth value, that is 500, and the width is 300 mm. Click on modify story bar, select beam, and longitudinal bar is HYSD 500, and the confinement bar is mile 250. Change the value of longitudinal rebar cover, that is 25 each, top and bottom, according to IS 1893. Click on OK. Click on. So we have to add copy of the property as we have did for column. Change the property name to beam 550 cross 350. Material is M40. Change the depth value, that is 550, and the width is 350. Modify story bar, no change because we have selected the copy of the first beam dimension. Click on OK. One more dimension we have to select, add copy of the property. Change the property name to beam 600 cross 400. Material is M40, depth is 600, and the width is 400. Click on OK. So add new property for the auto select. Change the property name to beam auto select. Change the select design type to concrete. Select all three beams which I have defined earlier. Add so and click on OK. Now we have done for them change. I have given the property for beam and column. So click on OK. Now we will define for the slab. Go to section property, slab section, add new property, that is slab 150, and the slab material is M40. Change the thickness to 150 mm. Click on OK. Click one more time OK. So we have defined all the properties. Now go to story number 1. First use the change similar story concept. Go to the story number 1. Now we will give the column. So using shortcut key, change the property to column auto select. And close the whole area. Go for the beam, change the property to beam auto select. Now go for slab, change the property to slab 150. Now go to story number 9, any of the story between 9 to 15 because it is similar, and do the same thing as we did for story number 1. So we have made beam, column and slab using the similar story concept. Now go to story number 15 to 19 in any of the story and do the same. So we have did for beam, column and slab in story number 15. Now do the same for story number 20 to 23 using this arrow key. So we have did for story number 20 the shaded we have made the beam, column and slab. Now go to story number 1 using the arrow key. Now we have to apply load on slabs and cladding. Since dead load is same in all story, select all story option from the similar story. Now select all cell one by one. So we have selected, make sure that it is 147 cells. Go to assign cell load uniform, and load is 2 kN/meter per square. Click on OK. So here load has been applied. Now we will apply live load for different story. Select similar story option concept. Now go. Now select all slabs one by one. Make sure that it is 72 cells. This time only the slab of stories similar to 1 to 8 is selected. That is 22 cells. Go to assign, cell load, uniform, change the load pattern to live load, and the load is 5 kilonewton per meter square. Click on OK. So the live load is applied to 1 to 8. Now go to story from 9 to 14. Make sure that similar slope story has been selected. Now select all the cells one by one. Go to assign, cell load, go to uniform, change the option to live load, and the load is 4.5 kilonewton per meter square. Click on OK. Now from stories similar to 9 to 14, the live load has been applied. Now go to story number 15 to 19 using the arrow key. Make sure that similar story has been selected. Now select cell one by one. Go to assign, cell load, uniform, load pattern is live, and the load is 4 kilonewton per meter square. Click on OK. So the story which is similar to story 15 has and the live load is applied for the similar story. Now go to story number 20 using the arrow key. So make sure that similar story has selected. Select the cell. Now go to assign, cell load, uniform, and the load is 3.5 kilonewton per meter square. Click on OK. Now all the load is applied. Now we are going to apply cladding load. Option is auto draw drawing. Go to story number 1 using arrow key. Select all story. All story to similar story. So carefully select the exterior beam. Go to assign, frame load, distributed. Uniform load is 0.2. Click on OK. So all the load is applied here. Now go to story number 9 using the arrow key. So make sure that similar story has selected. Now select the external beam, external, one by one. So make sure that 22 frame has been selected. Go to assign, frame load, distributed, load of 0.2 kilonewton, apply and OK. So the load has applied. Now go to story number 15 using the arrow key. So we have selected all the external beam here. Now go to assign, frame load, distributed, 0.2 kilonewton. Click on OK. So the external load has been applied here. Go to story number 19, 20 to 23 using the arrow key. So make sure that 24 frame has been selected. Go to assign, frame load, distributed, click on OK. So the load is applied here. Once we are done with with once we are done, we have to remove the cladding load from the beam of the topmost story, as there are no walls above them. Go to last story using the arrow key, that is story number 23. Select one story from similar story. Select the external one. Go to assign, frame load, distributed, delete the existing load, click on OK. So we have removed the load. Now go to the base, select one story which has already selected here. Select the whole area. Go to assign, joint, restring, make them fixed, click on OK. So here we are done. Now we have to apply pin load to external cladding. Go to define, load pattern, change the load to wind, change the type to wind load, select the IS code, add new load and modify lateral load. Wind speed is 33 meter per second in Bangalore according to IS code, and the terrain category is, it falls under the category 3. It's from clause 5.3.2.1 in IS code 193 part 3, and the structure class is C, that is greater than 50 meter height of any building, and risk coefficient is 1 and topography is also 1. Click on OK. Click on OK. Go to story number 1. Click on elevation and select section as A. Click on OK and select all story option here. So height of the building is 23 into 3, that is 69, and length and width of the building is 18 meters. So height by width ratio is comes down to 3.83, which comes under the category of length upon width ratio 3/2 to 4, which falls under category. So the CP value of A is 0.8. So here we have missed something, that is auto draw cladding. So we have done from draw auto cladding. We have done here, no need to worry, and select all story. Make sure that 41 cell has selected. Now go to assign, cell load, wind pressure coefficient, that is CP value is 0.8 according to IS 1893. Click on OK. Some parts under in section B also. So now select elevation, select section B. Okay, select 24 cell, go to sign, cell load, wind pressure coefficient, it is 0.8. Click on OK. Now go to plan, select story 1, click on OK. Go to elevation, select section D, click on OK. Now select all story, go to assign, cell load, wind pressure coefficient, that is minus 0.25 according to IS code. This time it's the leeward. Click on OK. Now again go to elevation, select section C, click on OK, select all, that is 24 set. Now go to assign, cell load, and processor coefficient which is same, click on OK. Click on elevation, select one, click on OK. Now select all the sets. Since CP is same for all, that is all elevation, that is section elevation 1, 2, 3, 4, that is minus 0.28. So go to elevation 2, select all, for elevation 3, and elevation 4. Go to assign, cell loads, pressure coefficient, that is minus 0.8, leeward, click on OK. Now for check, go to plan, select story 1, click on OK. So all the direction the load is applied. Now we have come to the final process, that is analysis. Before that, go to extruded view, so we have to do for the analysis of run. Go to analysis, as we have not saved, so we have to save here with any folder. Let's say build, now save. So we have saved. The analysis of the process of analysis has started. You can see the progress here. You can check the progress. Now go to the side, design, concrete frame, the revised reference, that is IS 456-2000, click OK. Now go to design, concrete frame, start design check. The process has started for the design check. We have seen that 705 concrete frame has failed. It means software has selected least dimension, that is 500 plus 500 for column and 500 plus 300 for beam. Ask for reiterated analysis. Okay, yes. Again it is showing that concrete frame has failed. Again click on yes. So no display pop-up. So last one we have to do. That is for passing all member. Go to concrete frame, design. You have did verify all member. So displays there all concrete frame as the design check. Click on OK. So thus we have successfully analyzed and designed tall building. For displacement, we can see here details which can be shown here. Reports may also be seen from here. It is been working, started working. So reports has made. So thus we have successfully analyzed and designed tall building using ETAP software, and also generated its project report along with detailed designing. Thank you.